In this video, we're going to be working on questions 21 through 25. We want to find the domain of the function f of x equals 32 over 6x minus 17. The domain is going to be all real numbers except for a list of numbers here. So as we look at this function, we notice that we have a variable in the denominator. This kind of function is called a rational function. And when we have a variable in the denominator, our concern is division by zero. Dividing by zero is an operation that is undefined. So we want to exclude any numbers that cause the denominator to be zero. So we're going to take that denominator, 6x minus 17, and we're going to set it equal to 0. We'll solve the equation by adding 17 to both sides. That gives 6x equals 17. Divide by 6, and we get x equals 17 over 6. This is the value that causes the denominator to be 0. And when the denominator is 0, the expression is undefined. So we're going to exclude 17 over 6 from the domain. On this example, we want to select all of the graphs that represent y as a function of x. So we really want to know whether these graphs represent functions. The definition of a function is that it has to have this special property where every x, each x has exactly one y. And we use a test that's called the vertical line test. To tell whether each x has one y. So what we do is we look at our graph and we draw vertical lines. And as we draw those vertical lines, we're going to be paying attention to the intersection points. How many times does that vertical line intersect the graph? So you can see on this first picture that I've drawn the vertical lines, each vertical line intersects the graph in one place. And this tells us that each x has one y. So this first graph is a function, y as a function of x. So let's do the same thing for the next graph. If I draw vertical lines, I'm going to pay attention to the intersection points. And I'll notice that on this vertical line, I have two intersection points. So for that vertical line, I know that that x value has two y's. On this one, I have three intersection points. So for that x, I have three y's. And since I don't have exactly one y, this is not a function. Let's try the next one. I'll draw vertical lines and pay attention to the intersection points. Each intersection point or each vertical line only has one intersection point. So this is the graph of a function. So we're going to select this one. We'll try the next one. When I draw a vertical line, I can see only one intersection point each time. So here's an intersection, here's one, here's one, here's one. So this is the graph of a function. On this example, when I draw, sorry about that. On this example, when I draw a vertical line right here, it intersects the graph in two places. So I have two y values for the x, so this is not a function. In the last graph here, every vertical line will intersect the graph in one place. So this is the graph of a function, and I'll select it. So we had two graphs that were not functions and four of them that were functions. On this example, we want to graph the equation f of x equals negative 4x plus 1. And there are multiple ways of graphing this equation. One way is to notice that this function is a linear equation. Negative 4x plus 1. It's linear because we have x to the first power, so we can think of this as y equals mx plus b. Y equals negative 4x plus 1. So this equation has a slope of negative 4 and a y-intercept of 1. So we'll plot that y-intercept of 1 and use the slope to get to a second point. So I'll go down 4 and to the right 1. That gets me to the second point on the line. And we'll connect those 2 points with a straight line. So you can use slope-intercept form to graph this line. Another option would be to plot points. You can make a chart of x's. Let's say we have negative 1, 0, and 1 as my x's. And we're going to find the y's. F of negative 1 is negative 4 times negative 1 plus 1. That's 4 plus 1, which is 5. F of 0, that's 4, negative 4 times 0 plus 1. 0 plus 1 is 1. F of 1 is negative 4 times 1 plus 1. Negative 4 plus 1 is negative 3. So you can plot those points, negative 1 and 5, 0, 1, and 1, negative 3, and you would connect those points with a straight line. My line looks a little bit different the second time because I didn't use a ruler to draw my line, but these two are the same line. On this example, we want to draw the graph of f of x equals 2 to the x. I'm going to plot points to draw this graph. I have a chart of x's and y's. And I'm going to choose x equal to negative 1, 0, 1, and 2. And we substitute these x values into our function. F of negative 1 is 2 to the negative 1. Having a negative in the exponent, if you apply it, you're going to do the reciprocal of your base. So that's the same thing as 1/2. F of 0 is 2 to the 0, which is 1. f of 1, that's 2 to the first power, which is 2. F of 2, that's 2 squared, which is 4. So now I have a few points to plot. -1.5, 0, 1, 1, 2, 2, 4, and your graph looks something like this. This is called an exponential function. Given the function f of x equals 2x squared minus 6x plus 4, calculate the following values: f of -2, f of -1, f of 0, f of 1, f of 2. When you calculate f of -2, the -2 is what we substitute in for x. Is 2 times -2 squared minus 6 times -2 plus 4. We're going to simplify following order of operations, applying the exponent first. -2 squared is 4. We can multiply. -6 times -2 is a plus 12. 2 times 4 is 8. Plus 12 plus 4, that gives us 24. So f of -2 is 24. Let's do the same thing with the next one. We have f of -1. We'll substitute -1 in for x. That gives 2 times -1 squared minus 6 times -1 plus 4. Simplify following order of operations. We'll apply the exponent first. -1 squared is a positive 1. -6 times -1 is a positive 6. We have 2 plus 6 plus 4. That gives 12. F of -1 is 12. Let's do that again with the next one, f of 0. 0 is what we replace x with. 2 times 0 squared minus 6 times 0 plus 4. We're going to follow order of operations and apply the exponent first. 0 squared is 0. 6 times 0 is 0. Carry down the plus 4. 2 times 0 is 0. Minus 0 plus 4 gives me 4. F of 0 is 4. Then we want to find f of 1. 1 is what we replace x with. It's 2 times 1 squared minus 6 times 1 plus 4. Apply the exponent first. 1 squared is 1. 6 times 1 is 6. We have minus 6. 2 times 1 is 2, minus 6 plus 4. 2 minus 6 is -4, plus 4 is 0. Last one, let's do f of 2. 2 is what we replace x with. We have 2 times 2 squared minus 6 times 2 plus 4. Apply the exponent. 2 squared is 4. -6 times 2 is -12, so we have minus 12. 2 times 4 is 8. Minus 12 plus 4. 8 minus 12 is -4. -4 plus 4 is 0. So f of 2 is 0. Let me double check my math there. So we have 2 squared is 4. 4 times 2 is 8. 6 times 2 is 12. And 8 minus 12 is -4. Okay. So we did get f of 2 being 0 there.
Thank you for checking out my videos. Have a great day.